Hello everyone, welcome back to our channel. We were discussing about trigonometric functions for class 11th Maths NCERT chapter 3rd. Today we'll discuss some formulas related to trigonometric functions. One type of formulas is trigonometric functions of sum and difference of two angles. Here, let us consider x and y as the two angles. So sum of the angles would be x plus y. There are two formulas related to it, sine x plus y and cos x plus y. Sine x plus y is sine of first angle into cos of second angle plus sine of second angle into cos of first angle. Cos would be cos of first angle into cos of second angle minus sine of first angle into sine of second angle. Difference of the angles would be x minus y. The formulas for sine and cos respectively are sine of x minus y is equals to sine of first angle into cos of second angle minus sine of first and second angle into cos of first angle. Cos of x minus y will be cos of first angle into cos of second angle plus sine of first angle into sine of second angle. Now, a proof for this particular formula, and later we can derive this other formulas using the same proof, is given in your text. I'm not explaining the text because it's not very important from a problem solving perspective, but if you want an explanation for it, you can let me know in the comments, and I will make another video on the proof of this particular formula. Okay, so using this basic formula, these four basic formulas, we can derive all the formulas that we studied in the last class, which was trigonometric functions, formulas for trigonometric functions of allied angles. Secondly, you can, for example, let's derive one formula. Let's say we want the formula for cos of pi plus pi by 2 plus theta. Now, we know that pi by 2 plus theta means this comes in the second quadrant. Since it's pi by 2, your cos value will be converted into sine value. Pi by 2 plus, in the second quadrant, cos is negative. So this would be minus sine theta. This is from the explanation, from the understanding explanation that we have seen in the last class. Now, let's see if we get the same result using the formula. Cos of first angle plus second angle. So here your x is equals to pi by 2 and y is equals to theta. Putting it in this formula, cos of x plus y. Your RHS is cos of first angle into cos of second angle minus sine of first angle into sine of second angle. We know that cos of pi by 2 is equals to 0. So 0 into cos theta minus sine pi by 2 is 1 into sine theta. This is equals to minus sine theta. So if you forget a formula of trigonometric functions of allied trigonometric functions of allied angles from the last class, you can apply this formula. However, it's always recommended to memorize the trick because it will save your time by problem solving. Next type of formulas are, for the same section, we can write the formula for tan of x plus y. Tan of x plus y is equals to tan of first angle plus tan of second angle upon 1 minus tan of first angle into tan of second angle. Similarly, if you want for tan of difference of angles, it will be tan x minus y is equals to tan x minus tan y upon 1 plus tan x tan y. You can write this formula in a combined fashion as well. You write both these formulas in a combined sense, which is tan of x plus minus y. By plus minus, you mean you're considering two values of this particular expression. One value is x plus y and another value is x minus y. So there are two values, but you're writing it in a combined fashion. This value is equals to tan x tan y. Now, if you can see in the first formula x plus y, you have a plus sign, addition of tan x plus tan x and tan y. For x minus y, you have tan x minus tan y. That means tan of first angle minus tan of second angle. So first is written first. This plus sign, the top sign is related to the top sign on of left hand side. The second sign is minus on both sides. In denominator, you have 1 minus plus tan x into tan y. How is this? For plus, you have a negative in the denominator. For the first sign, you have a negative. For the second sign, you have a positive. For second sign, you have positive. So this is the combined way of writing both the formulas. Similarly, for cot, we have this formula. Cot of x plus minus y is equals to cot x into cot y minus plus 1 upon cot y plus minus cot x. Observe that the second angle of cot comes first in the denominator and the first angle of cot comes second in the denominator. Now let's try and see if we can find a way to memorize or find a trick to memorize this. The only trick you have is find a correlation between different formulas. So for sine, if you see over here, for sine, x plus y, you have a plus sign in the middle of two terms on the right hand side. For x minus y, you have a minus sign over here. For sine specifically, you have sine into cos, sine into cos, sine into cos, and sine into cos. First formula, sine will take, in the first term, sine will take the first angle. In the second formula, sine will take the second angle, and cos will take the second angle in the first term and the first angle in the second term. I said formula, it should be term. For cos, we have cos x plus y, cos x, cos y. That means cos term plus on the left hand side means minus in the middle, and minus on the left hand side means plus in the middle. So cos term first, and second term is sine. So by correlation, by comparing few formulas of same type, you can memorize it better. Here also in tan and cot, you can form a comparison. So in these four formulas, tan x plus y, first term tan x, tan y, tan x, tan y. In cot, it's the reverse fashion. Cot y, cot x. That means you have tan x plus tan y plus because of this plus, minus because of this minus. In the denominator, you have the opposite sign. If you have plus in the numerator, you have minus in the denominator. If you have minus in the numerator, you have plus in the denominator. Similarly, in cot, it's the same. If you have plus in the numerator, you have minus in the denominator. If you have minus in the denominator, you have if you have minus in the numerator, you have plus in the denominator. For the first sign, you have cot x plus y, minus in the numerator and plus in the denominator. For the second sign, minus, you have plus in the numerator and minus in the denominator. If you can compare this tan and cot, they are opposite of each other. Your two terms, tan x plus minus tan y, is in the denominator here. Cot y plus minus cot x. The denominator part of tan, 1 minus plus tan x tan y, is in the denominator, cot x into cot y minus plus 1. To get used to these formulas, there are only two methods. One, look at the formulas daily for a month and try to memorize it, try to think about it during your day. Second, solve as many problems on these formulas as possible and try to recall the formulas rather than looking at the formulas and then solving the problems. Or you can even memorize 5 formulas daily and then brush it up or revise it by the end of the week. There is a condition for this tan x plus y and cot x plus y. The condition states that these angles x or y or x plus y or x minus y, these are the angles or combination of angles. All these values in tan, they should not be odd multiples of pi by 2. They should not be equal to 2n plus 1 into pi by 2. That means they can hold any value except for this value. Here, in cot x plus y, all the angles which are x, y, x plus y, and x minus y, they should not hold the value of integral multiples of pi. That means they should not have n pi as their values. N can be any integer. N belongs to z in both the cases. Next, let's move on to double angle formulas. Now, what are double angle formulas? If I write cos x, x is the angle over here. But instead, if I write cos 2x, that means I'm multiplying the angle by 2. The whole cos value is not multiplied by 2, but the angle is multiplied by 2. Here, in this case, you have some standard formulas for cos 2x, sin 2x, and thereby you can even derive the formulas for tan 2x and so forth. Cos 2x will be equal to cos square x minus sin square x. We already know the trigonometric identity that sin square x plus cos square x is equal to 1. Observe you have a minus sign over here and the first term is cos square x. Cos square x means you're taking the square of cos x. Cos x would be single angle and cos 2x would be double angle. Sin square x plus cos square x is equal to 1. If you take sin square x on the right hand side, your cos square x becomes equal to 1 minus sin square x. Now, if you place this value of cos square x over here, your formula gets converted into 1 minus sin square x minus sin square x. This can be merged together to form 1 minus 2 times sin square x. Observe it is not sin 2x, it is sin square x. That means whatever value of sin x you have, you can just take the square of it. If you have the value, you can put it in the formula and get the value of cos 2x. That means cos 2x value can be obtained if you know both the values of cos x and sin x, or if you know the value of sin x. Another variation of the same cos 2x can be, we know that cos 2x is equals to cos square x minus sin square x. With the trigonometric identity, we can also write sin square x is equals to 1 minus cos square x. Like instead of taking cos square x on the right hand side, we've taken sin square x on the. Instead of taking sin square x on the right hand side, we are taking now cos square x on the right hand side to obtain the value of sine square x. This sine square x value can be placed over here. You can have cos square x as it is. Sine square x you are substituting as 1 minus cos square x. This is equals to cos square x minus 1 plus cos square x. This is equals to 2 cos square x minus 1. So cos 2x. This is a formula for cos 2x. Next, sin 2x. So sin 2x is equals to 2 times sin x into cos x. Now you might wonder, how did we come up with this? Why can we write cos 2x is equals to cos square x minus sin square x? We already studied the formula cos x plus y is equals to cos x into cos y minus sin x into sin y. If I substitute y is equals to x, you can write cos of x plus x is equals to cos x into cos x minus sin x into sin x. This will be equal to cos 2x is equals to cos square x minus sin square x. This is why we wrote cos 2x as it is. We can similarly we can derive the formula for sin 2x. Sin of x plus y is equals to sin x into cos y plus cos x into sin y. If you write y is equals to x, you can write sin 2x will be equal to sin x into cos x plus sin x into cos x, which is equals to 2 times sin x into cos x, which is what we wrote over here. Next, here we can now get the value of double angle for tan. Tan 2x. Tan 2x can be written as 2 tan x upon 1 minus tan square x. You can derive this formula from tan x plus y formula. These formulas, these double angle formulas for cos and sine can also be represented in terms of tan. Let's see. So sin 2x can be written as 2 tan x upon 1 plus tan square x, and cos 2x can be written as 1 minus tan square x upon 1 plus tan square x. There are some conditions as well in these double angle formulas. In all the formulas, cos 2x, sin 2x, tan 2x, your x should never be equal to an odd integral multiple of pi by 2. So in all these formulas, there's a common condition that your x should not be equal to odd multiple of pi by 2. Now, if you open this bracket, you can easily say that x should not be equal to 2n pi by 2, 2 gets cancelled, plus pi by 2, or x should not be equals to n pi plus pi by 2. This is what is directly written in your text, but it is derived from this, that x should not be equal to odd integral. This is odd integral multiple, this multiplication sign, multiple of pi by 2. Next, Next type of formulas are cos C plus cos D. Now you're adding two cos terms with different angles. So addition. Second combination would be subtraction of this two terms. That means cos of first angle minus cos of second angle. To differentiate these formulas from the rest, I'm using a different notation. I'm not using x and y. Your text uses x and y instead of c and d. You can have sine of first angle plus sine of second angle, or you can have sine of first angle minus sine of second angle. So cos of first angle plus cos of second angle. What happens here is two terms get converted into a single term. So this is equals to 2 times cos of average of two angles. You're adding the two angles and then you're dividing by 2 multiplied by cos. Cos, because this is cos. Cos of first angle minus second angle divided by 2. So your addition, your two terms got converted into a single term. Cos of first angle minus cos of second angle will lead you to 2 times sine of again average of two angles into sine of second angle minus first angle divided by 2. Observe C cos C minus cos D. That means here C is your first angle and D is your second angle. Second angle minus first angle divided by 2. If you take minus sign common from the second term, you will get C minus D upon 2. We know that sine of minus x is equals to minus sine x. Sine of minus x is equals to minus sine x. So if you take minus sign common inside in the angle part, then that minus sign will be introduced outside sine. So it can be rewritten as minus 2 sine of c plus d upon 2 into sine c minus d upon 2. Sine c plus sine d. Here you have 2 times sine of c plus d by 2 into cos of c minus d upon 2. Sin c minus sin d will be equal to 2 times cos of c plus d upon 2 into sin of c minus d upon 2. For sin values, if you have sin c plus sin d or you have sin c minus sin d, your answer, your right hand side will be sine of something into cos of something, or cos of something into sine of something. The sine comes first, c plus d upon 2, your average part in angle comes with sine when you have the addition of two sines. If you have subtraction of two sines, then cos term takes up the average and sine terms takes c minus d upon 2. Next, what happens if you add the two values, like of cos, if you add the two values of cos x plus y and cos x minus y, all you have to do is add the two equations in the add the two equations that we earlier studied. If you add them, you'll get 2 times cos x into cos y. What happens if you subtract them? Cos of x plus y minus cos of x minus y. Then you get minus 2 sine x into sine y. Sine x plus y plus sine x minus y. You're adding two sine terms. You'll get 2 times sine x into cos y. Sine of x plus y minus sine of x minus y will lead you to 2 times cos x into sine y. Observe x minus y. So x takes the first angle and y takes the second angle. It's assumed that x is greater than y. Now, these above formulas can also be derived from these formulas. For example, if in place of x plus y, we place c as a variable, as an angle, in place of x minus y, we place d as an angle over here, your right-hand side, x gets transformed into c plus d upon 2 and y gets transformed into c minus d upon 2 in all these equations. However, from exam point of view, you have to memorize both the equations, these first 4 and this last 4. The next topic that we have in our text is trigonometric equations. Now we know that an equation can be something like x squared plus x plus 1. This is quadratic equation. Instead of x, if I place it as sine x, if I take sine x, so sine square x plus sine x plus 1. So instead of your variable directly, your variable in the terms, you have trigonometric functions of those variables. Your final answer, your final solution is still the value of x. It's not the value of sine x that you're seeking for. You're still seeking the value of x. But now your x value, your variable, is the angle of the trigonometric function in your equation. So here you can have either principal solution or general solution. Now, when you say you want to find the solution of the original x squared plus x plus 1 is equals to 0 equation, you have to find the value of x. Here also, if you have to find a solution, solution means finding the value of x. But your x is an angle of sine, and we know that sine can have the same value for multiple angles. You have allied angles in sine in your trigonometric functions. For example, sine 0 is equals to 0. Similarly, sine pi is equals to 0. And sine 2 pi is equals to 0. So, you can have the same value of 0 for multiple values of x. So, while solving an equation, how will you know that which value should you consider? Which value of x should you consider? What is your final value? So, if your value of x lies between 0 and 2 pi, after solving the given equation, if your value of x lies between 0 and 2 pi, you'll call that solution as your principal solution. However, if you are taking general value of x, then here this can be written as sine of n pi is equals to 0. That means instead of mentioning individual values of x, which would be multiple in nature, which would be infinite in nature, you have represented that angle in terms of an integer n, where n belongs to z. So x is represented in the form of an integer. X is an integral multiple of pi over here in this equation. So if you represent your value of x in terms of integer, small n, where n belongs to z, then it is called a general solution. So we will stop here. This ends the introduction part of your trigonometric functions. If you want a repetition of any of the concepts, or if you think that certain concepts, certain additional concepts should be explained, let me know in the comments. So I'll take up those in my next videos, and I'll add them to the playlist so you can watch them there. Thank you.